Okay, today we are going to be programming for the Bevel gear robot. So let's go ahead and create program. And we're just going to do a blank robot. Make sure you're always putting your first name and then the name of the robot. So in this case, mine would be Miss C, and then this is the Bevel gear robot, so Bevel gear. So like always, we're going to set up our schematic editor first before we program on our block diagram. So I'm going to open schematic editor. And I want to make sure that this is on NXT. For sensor port 1, we have our HDDC motor controller, which has two motors, our two DC motors. And I need to relabel these as left wheel and right wheel. And then we need to not forget to click the box to reverse the left wheel. So the motor controller is daisy chained to the HT servo controller. And we will just have one servo, so one Tetrix 180 servo. And let's go ahead and rename our servo. In this case, I'm going to name mine Sonic Servo because our servo is going to be helping our ultrasonic sensor. In sensor port 2, we should have our Lego ultrasonic. Sensor port 3 will be our Lego light. And sensor port 4 is going to be our Lego touch sensor. So that's everything that you should have on your schematic editor. Don't forget, if you have the little star at the top, that means you haven't saved it yet, so make sure you click save, and then we can go ahead and close our schematic editor. So I'm going to create a new VI, and this will always be VI for NXT V3 target. You use the same name that you use for your project, so your first name, and then Bevel gear. And I can go ahead and minimize the front panel. It's the block diagram that I want. I'm going to right click to get my functions palette, and I'm going to click the push pin to make it stay. Looks like I'm missing my labels, so I'm going to go to customize and view my palette as icons and text. Okay. So now we're ready to program, and what this program is going to do is have the robot use the ultrasonic sensor to look around to see if anything is in its way. If it doesn't see anything, then it's going to go ahead and move forward and then scan again. If it does see something, then we wanted to terminate the program. So in our program, the first thing we need is our while loop. So that's under programming and structures, and we're going to take a while loop and drag that out. Then we're going to go ahead and put our servo block inside there. So our servos, remember, are I/O under the advanced motors menu, and we want move servos. I need to tell it which port my servo is in, so I'm going to right click create constant on the top. And then I want this to be reusable in my program, the initialize box. So I'm going to click and drag like I'm selecting a picture. I'm going to drag that to the outside. That way it's more reusable for the rest of my program. I need to reconnect my wire. That broke. Looks like I got an extra one here. And I need to choose my Sonic Servo. We have to give it a starting position, so I'm going to create a constant for position 1. And this one is going to be 27 for our position value. So then the next thing we need to do is to create a for loop. So I'm going to move this over a little bit. I need that from my programming menu, and structures and for loop is what we want. So drag that out. So our for loop goes for a certain amount of time. In this case, for my number of time up here at the loop count, I can create constant. I'm going to put 200, so that way this loops 200 times. Then I need to add some of my shift registers. And what these are going to do is remember the value that it had before for the loop, and it's going to take and carry that value over to the next loop. So on the border of my for loop, I can right click and I'm going to add shift register. We're going to do that one more time because I want 2 of those. So it looks like that. Move my servo up a little bit. For our shift registers, these two, it won't let you create a constant on them because it doesn't know what data type you want to use yet. So instead, what we're going to do is go into the programming menu and go to numeric. And down at the bottom of numeric, there's numeric constant that we can use. So I'm going to need 2 of those. And if it doesn't auto wire, then you can go ahead and wire it to your shift register, and that will change the color to blue to data type, which is going to be whole numbers. The first one should be 50, and then the second one is -1. Inside this for loop, I want to use my screen update sub VI. So to do that, we need to make sure that our screen update is in our project folder. So I'm going to go back to the main project screen, and I'm going to add VI. And in my downloads folder, I have screen update. If you have not downloaded that file, you need to download that file. And we're going to add that VI to our project folder. And when the program comes up, which it has, then I can take this block in the corner and drag it onto my program. So then I can copy and paste the screen update as many times as I want. I can also close out the screen update program. I do need to wire my NXT wire because that determines order for the program. I'm going to also have another move servos block. So it's IO, advanced motors, and move servos. Connect to my NXT wire. This is going to be the same servo in the entire program, all talking about the same one. So I'm just going to go ahead and wire it to the first servo that I had, since it's the same servo. We also need to have, for the servo position, we're going to change it depending on, in this case, these 200 loops. So I want to go to my programming menu, and I'm going to go to numeric, and we want an add triangle. So the very tip of that add triangle is going to be the input for position 1, so I'm going to wire that up. The X value, so the input, I'm going to create a constant of 27. And then for the Y value, that will be plugged into this loop iteration right here. And all this loop iteration is doing is keeping count of how many times it looped. So it's going to loop 200 times total, and that's what this loop iteration is going to keep track of. So it's going to add that number, 227, to get the position of the servo. The next thing that we need then is for our shift registers, and that's going to be a case structure. So I'm going to take from my programming menu, structures, I'm going to take a case structure, and I'm going to drag this out. Then my shift registers, so this 50 right here, I'm going to go ahead and wire that through my true to my true. And then I'm going to also wire my -1 to my true. My shift register on the other side, so my top one that would originally go to the 50, this one, I'm going to click on the border for my case structure. And then this top shift register is going to be connected. So I'm going to connect one more time to the border, and then this is going to connect to my sonar distance. So make sure you're choosing sonar distance, so that middle dot on the screen update. The bottom right register, so this one right here, I'm going to wire it again. So it's helpful if you click on each border as you go, so that way it has a stopping point. This bottom one is going to be wired to that loop iteration. It's right there. So I'm going to go ahead and switch to false in my case structure. And in the false, I'm going to go ahead and wire my shift register that has the 50. I'm going to go ahead and wire that just all the way across to the other side. The shift register that has the -1, same thing. I'm going to wire that all the way across to the other side. So I have both my true and my false wired. All your boxes on the border should be full, should be filled. If they're not filled, that means then in the other case you don't have it connected to something. So then the last thing we need to do is have something that chooses the true and false for this case structure. So this green little question mark box, this case selector, is the one that decides whether to run true or whether to run false. And it takes in a Boolean value, so it takes in true or false. So I'm going to need then a comparison to send out true and false for me. So I'm going to go to Programming, Comparison, and I want a less triangle. So I'm going to put that less triangle down. The very tip of that triangle, so that green dot, x less than y, that's what sends out true or false. And I need to connect that to the green question mark box, the case selector box. The input for less, so the x value, is going to be wired to my sonar distance of the screen update. And then the comparison, so what we are comparing to would be our y value. I want that to come from the shift register. So this 50, the shift register, I'm going to go ahead and connect to that wire. So if I hit my cleanup diagram right now, okay, I should wire it a little bit better. And we are done with this first area, but I need to put more in this big while loop. So I'm going to drag this while loop out because we need to put the rest of our code in there. And then the next thing I need to do is put another move servos. So I'm going to go to IO, my advanced motors, down and move servos. and connect my NXT wire for order. Anytime your box looks like this, where it's not filled, you just right click on it, go tunnel mode, and last value to fix that. This servo is the same as the one before. We're using the same one. So I'm going to go ahead and connect that. And then as far as position, so position 1, I'm going to create a constant of 127, so 127. I want my robot to pause in between each action, so I'm going to go back to I/O and put down a wait for block. Connect my NXT wire. I'm going to create a constant for the time it needs to wait. In this case, let's do 0.5. Let's have it wait for a half a second. Okay, so then we do need one more case structure. So I'm going to go to Programming, Structures, and I want a case structure. Go ahead and drag that out. Inside the case structure, if you switch this to false, the false isn't going to have anything in it, so I'm just going to go ahead and wire the NXT wire all the way through. And notice that's a white square there because I don't have it wired in the true case to anything. So false goes all the way through the NXT wire. True is going to have some stuff in it. It's going to have another case structure. And I need to do some wiring here. I'm going to take the top shift register. So this was the one that was connected to the 50. I'm going to take that top shift register and I want to bring it through, wire it all the way through. Let's stop there. Okay, wire it all the way through to my case structure. The bottom shift register is going to need an extra thing. It's going to need, in our programming menu, in comparison, I want the not equal. So not equal triangle. So then the bottom shift register, so the one that's connected to the -1, will be the input for that not equals. The bottom, so what I'm comparing to, I'm going to create constant and have it compared to -1. And the very tip of this triangle, so what sends out true or false, is going to determine this outer case structure. So I'm going to wire it to the green question box, the case selector box. We need something to control this inner case selector also to send true or false there. So I'm still going to use a comparison. This time I'm going to use a less triangle. The very tip of that is what sends true or false, so I'll connect it to my case structure, my case selector for my case structure. The input, so the X value for this, is going to come from our shift register. So I'm going to connect this to the wire that is the shift register for -1. And then I have to have a number to compare to, so the Y part, what I'm comparing to, I'm going to create a constant, and this one is going to be 100. So inside this innermost case structure, so notice I am true, true, so I'm on true here. I'm going to go ahead and have it move my motors. So I'm going to go to I/O, move motors, and we haven't used this yet. This is for our DC motors, so I'm going to go ahead and create my constant. And I want this to be my 2 DC motors, so I'm going to click the arrow down. The red one is going to be my left wheel. The blue one is going to be my right wheel. And I want to make sure that I can share this initialize box for the other DC motors, the other move motors, later on in my program. So I'm going to click and drag like I'm selecting a picture, so only this is highlighted. And I'm going to bring this initialize box back to the beginning of my program, because we like to put all our initialize boxes in the beginning. And then I just need to reconnect my wire to my move motors. Okay. So in this case, I want my power and speed one. I'm going to create constant, and that's going to be -15. Power and speed 2, create constant. That one's just going to be +15. I want my screen update again, so I can either click and drag from the screen update window, the program window, or I can just copy and paste. So Control C, click where I want to paste at, Control V, copy and paste that down. And this is going to involve my line follower part. So we are going to have the motor power switch, but I do want to keep running these motors until it determines that it needs to stop. So to do that, I'm going to put a while loop. So I'm going to go back to programming and structures. And I'm going to put a while loop just around the move motors and the screen update. So I'm going to go ahead and wire my NXT wire for order. And I need to have something stop this while loop. So I need to send in a true or false value to this loop condition. So in our programming menu, if we're going to grab a few blocks, we're going to grab from the comparison menu. We need a less than or equal. And then I'm also, from the programming menu, I'm going to go numeric, and I need an add. So it puts down those 2 triangles. So on the screen update, I want to wire the sonar distance as the input for my less than or equal to triangle. The output should be sending that true or false, so that's going to be wired to my loop condition to stop the while loop. And the comparison that's going on here for the Y, I'm going to go ahead and connect the tip of the plus, the add triangle. That's going to send in the value to compare to. For the plus, what it's adding on the bottom here in the Y, I'm going to create a constant and make this 2, so that way it adds 2 every time. And then the input, so what's being sent in for the X value, is going to be my value from my shift register. And it's the top shift register, it's the one that has the 50, which I put it on the border here so I can easily access it. I'm going to save just in case something happens. Okay, there you go. And then I want to switch from true to false. So inside the false, it's going to be the exact same thing as what we had in true. So if we look at true again, the only difference is, since this is going to be my line follower program, these two powers are going to switch. So that way it's doing positive 15 for one power and negative 15 for the other. So you can either, because we're going to take this entire while loop, you can either copy and paste the entire while loop. So I'm going to switch this to false. I'm going to paste this down. I'm going to drag the border to get it to move a little bit. There we go. So you can either copy and paste it, or you can just recreate it. But you do need to, if you copy and paste, you're going to have to reconnect your wires that broke. Looks like I lost my wire for the power of 15 too. There we go. And the only difference is the motor powers. So it should be positive 15 for the red, for the left wheel, and negative 15 for blue, for the right wheel. Okay. Outside this innermost case structure, once this is done, I want to make sure my robot stops. So I'm going to go to I/O, and I want to take a stop motors. And I'm going to put this outside the innermost case structure. I need to wire the motors to the motor wire so it knows which motor to stop. And then I'm going to go ahead and wire my NXT wire all the way through. Looks like since I have an empty white square here, I also need to do that for my true case. So I need to wire my NXT for order. Okay, and I'm going to save. And that will be the case structures completed. So now we're on to the last part. We want to put in a timer, and the timer is actually considered a sensor. So under my I/O menu, I'm going to put down a sensor, and for the drop downs, I'm going to do read timer. And I'm going to connect my NXT wire, and I need to put in one last while loop. So inside my while loop, I'm going to put a move motors. I'm going to connect my motor wire so it knows which motors I'm talking about. Bring through my NXT wire for order. The power for the motors is going to be 15, so I'm going to create a constant of 15. And I'm going to make sure power and speed 2 also uses that 15. For my for my timer, I need reset timer for this one. Sorry, so this timer that I put down, that one should be reset timer if you just go down into the drop down. We do have another timer, which is a sensor block. That one is just the regular read timer. And I can connect my NXT wire. I'm going to go ahead and copy and paste my screen update block. Connect my NXT wire. And then inside this while loop, we're going to have a few things going on. I'm going to go ahead and put in one more case structure. So it's under Programming, Structures, Case Structure. Put it down here. So I'm going to go ahead and put down some triangles, some programming triangles. So first one I need in programming and comparison, I need a grader. So I'm going to put that in between the timer and the screen update. I need a less than, so less, that's going to be on the right side of the screen update. I want a less than or equal to, that'll be on the left side of the case structure. And then I need one more, which will come from Boolean. So programming and Boolean. And in this case, I want this OR. I'm going to put that a little bit below my less than triangle. Looks like it automatically wants to connect. We'll connect it in a minute. Okay, so now we just need to do some wiring here. So my timer is going to send in a value to the input of the grader triangle. The grader triangle is going to get a value from my case selector. So I'm going to go ahead and wire that to my case selector. And then I can go ahead and, oh, looks like it doesn't want me to do it that way. Okay, so let's do it this way. We're going to right click, create constant. And I'm going to take that constant and move that inside my case structure so I can rewire that. That constant should be 500. And the very tip of this grader then is going to be sent in to this OR right here, this block. So the bottom, so the Y part of that. This less than or equal to, the very tip, that true false is going to choose which to run, true or false. The false case, so if we switch to false and we create a constant on that little block, this one is going to be 1000. For my less than or equal to, the very top, so the input, the X part, is going to be wired to my shift register. And I want to wire this to the 51, which is my top one. So here's my 50, my shift register. I'm going to wire it out here. And then the bottom of the less than or equal to, I need to create a constant, and this is going to be 30. My screen update, the sonar distance is going to be the input, so the X value for the less than. That's going to compare to a constant. So on the Y, I need to create a constant of 15. And that true or false being sent out, so the very tip, is actually going to be sent into this OR block. So the very tip of this OR block, this X or Y, is going to be what's controlling this innermost while loop. The outermost wire loop, so this loop condition, will be stopped also by this less than. So I'm going to go ahead and wire this less than. That true false value being sent out, I will wire that to the loop condition on the outside. And then the last thing we need is just to make sure our motors stop in the end before it runs into something. So I'm going to go to I/O, stop motors. I'm going to put that on the inside of my while loop, my outermost while loop. I need to wire my NXT wire for order, and then I need to tell it which motor, so I can connect this to the motor wire because it is the same DC motor wires. So I'm going to go ahead and save just in case. I'm going to click on my cleanup diagram, which is going to squish along your pink NXT wire. And as long as you have it wired the same as mine, and you don't have any errors, so that means your arrow up top is solid white, then you are done with the program.